Hello, everyone. Welcome to section 1.8, Inequalities. This is an addendum to the original lecture. I realized that I glossed over a detail about rational inequalities that's important to note and will come up in your homework. And it is this. So for rational inequalities, and so remember, that's when you've got a polynomial over a polynomial and you've got an inequality. Here it is. So be careful when looking at the endpoints of your intervals. So when you solve a rational inequality, your solution will look like an interval. And if your inequality is something of the form, like something like this, maybe. So you've got 3x over x minus 2 less than or equal. So if you have a less than or equal situation, you need to be careful with the endpoints of your intervals. And it's best if I demonstrate why. So if we go through the usual process, you can find that the factors of this are clearly, 2 and 0. And if we make our little chart, like usual, so negative infinity to 0, 0 to 2, and then 2 to infinity, and then 3x, x minus 2, and then, of course, the whole thing, 3x over x minus 2. And then we do the usual. So 3x, that's going to be negative, and then positive and positive. And then negative, negative, positive. And then down here, negative times negative is a positive. And this one's a negative, and positive times positive is just positive. And if you want to see that sort of process in more detail, I recommend you go back and watch the main lecture. Now, from here, what we would say, since we have a less than or equals to, we want to focus on the negative, so this right here, and because it's equals to as part of it, we would say that the answer would be 0 to 2. But here's the problem. This is actually not the correct answer. No. Okay, and the reason for that is imagine, so what we're saying is that, so this answer says that, 3x over x minus 2 is less than or equal to 0 when x equals 2. But the problem is that if you plug in x equals 2, you get 3 times 2, that's okay. And then you get 2 minus 2 on the bottom. And then you get 3 times 2 is just 6 over 0. That's the issue here, is that the interval that you have has a point where it breaks math. And we don't want to do that. And so when you're looking at rational inequalities, there is one last step if it is a greater than or equal to or less than or equal to. The last step is check the endpoints. Again, you don't have to do this if it's a strict inequality. And so for this, this would look like, if we've got x equals 2, we already kind of looked at that, right? You get 3 times 2 over 2 minus 2, 6 over 0. That's bad. So 2 not included. But if we look at the other endpoint, which if you remember is 0, and we plug in 0, we get 3 times 0 over 0 minus 2. That's going to be 0 over negative 2. That's okay. Because, 0 divided by a number, we know how that is. That's just 0. We just can't have 0 on the bottom part. Okay? So your answer is actually going to be the same interval we did last time, right? But this time we want to take away the endpoint that's bad. And if you look at this on a number line, you'll see that the simplest way to represent this interval is just 0 to 2, open bracket. And this right here is a good answer.